All right, so today we're in 9.3, finding cube roots. Do you guys remember memorizing your perfect squares? Can we say them? Perfect square starts with 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 16. 5 times 5, 25. All right, so let's say all our perfect squares from here. 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. All right, so those are my perfect squares, meaning that I can evenly square root of that number, okay? So just like we learned perfect squares, you're going to learn perfect cubes. What does that mean? That means now a number is being multiplied by itself, not 2 times, but 3 times. Okay? So in 9.1, you learned that squaring a number and finding the square root undo each other. Like if it was the square root of 4, but then I try to square it. Do you guys remember that? That those two operations actually cancel each other out, and my answer would just be 4. So just like that was true, taking the cubed root of a number and cubing it, those operations undo each other. And the answer would just be that number. All right? So squaring a square root or cubing a cubed root, those operations cancel each other out. Those operations cancel each other out. All right, so let's say our perfect cubes together. And this number means that it has a factor that can be multiplied by itself 3 times. Okay, so 1 is obvious, right? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So what I want you to do is I want you to write in these perfect cubes and their cube roots. Okay, so for 1, it's 1. 8 is 2, 3, 4, and we're going to say them in a minute, 5, 6, 7, 8, 9, and 10. All right, so my perfect cubes are listed on top, and the cubed root is listed on the bottom. Having these memorized is going to be a huge help. Your calculators do not have the cube root function for a reason, because when you take the SAT and ACT, you won't have those functions available to you. So you have to have a way, you have to have a resource to find these numbers without a calculator. Well, one of your greatest resources is your own brain. If you have these memorized, it's going to save you a ton of work. It'll save you a lot of work. All right, so go ahead and write those in, please. All right, so this next part is not in your notes packet, so you can go ahead and turn to your 9.3 classwork. And I want to talk to you a minute about finding the square root or the cubed root when it's not obvious. It's not one of the ones that we have memorized, okay? Because, again, you're not going to have a calculator function to help you, okay? So how can I find the square root of 324 if I don't have a calculator function to help me? All right, and here's how we would do it. We're going to do something that should be familiar to you called upside down division. Do you guys remember upside down division?
I know that.
Okay, upside down division. So with upside down division, my rules say that I have to divide by only a prime number. Does anybody remember what a prime number is?
Any number that doesn't divide by itself.
Okay, it goes in 1 and the number itself are the only factors. So 2, 3, 5, and 7 are our most common prime numbers that we'll divide. I want you to choose the smallest prime number to start with. Okay, well, if it's an even number, I know that 2 goes into it, right? Okay, so you can use your calculators to do the division part of this. You just can't use them for the square root or the cubed root. So 2 goes into 324 how many times? Anybody tell me?
162.
All right. Now I can do 2 again to get 81. But 2's not going to go in anymore. What would go in? How do you know that 3 is divisible? Just by looking at the number. Does anybody know the trick? If you can...
8 plus 1 is 9.
Yes, add the digits together. 8 plus 1 is 9. 9 is divisible by 3, so I know 3 will go into 81. How many times? 27. 3, 9, 3, and 3. So now that I have my prime factorization, my rule says to circle, because it's the square root, which square root is 2, right? I'm going to circle my sets of 2 prime numbers. So do you see how I have a set of 2 right here? Okay, it's kind of like GCF a little bit. Now I have another set of 3s and another set of 3s. And for each set, I'm going to write it one time. So I had one set of 2s, another set of 3s, and another set of 3s. What is 2 times 3? 2 times 3, 6. And what's 6 times 3? 18 is the square root.
I got it right.
18 is the square root. Okay, all right, so that's how I would figure it out. I want you to try the upside down division for 625. This one won't be quite as long. Okay, so 5, 125, 5, 25, 5, and 5. Okay, so I have one group of 2 and another group of 2 5s. So for each group, I write it one time, and I multiply them together to get my square root. 25 is my square root. Okay? All right, so now we're going to do that with cubed root. Okay, so to find the cube root, I'm still going to do the upside down division the exact same way. Now remember, this is when you come across a number that you don't have the perfect cube memorized. So do you think you're going to want to do this on every single one? No, the more you can memorize, the better. Because that's going to save you having to write all this work. So 1728, you're like, oh my goodness, that's a huge number. But it gets smaller pretty quick, right? Because I'm going to divide it by 2. And what do I get when I divide it by 2?
864.
Mm-hmm. Now I'm going to divide it by 2 again.
Why would you just divide by 2?
You always divide by the smallest prime number to keep all your numbers grouped together. So these are all divisible by 2 because they're even numbers.
So if we were to,
All right, so we get to 216. And we get to 108. Lots of 2's, huh? 54. All right, and we broke the streak of our 2's. 2 goes into 54 27 times. And now I have 3 and 3 and another 3. Now remember, guys, this is the cubed root. So now I have to have a group of 3 to count it towards one of my factors that will be the cube root. So do you see how I have one group of 3 2's? So you write the 2 one time. Now I have another group of 3 2's, so I write another 2. Now I have a group of 3 3's, so I write another 3. What's 2 times 2?
4.
What's 4 times 3?
12.
So 12 is the cubed root of 1728. Okay, so do you see how we did that? Otherwise, guys, you're just going to be like randomly trying to guess at what the cubed root is. So this gives you a strategy that you can use to solve this every time. All right, I know 4,096, you're like, what? That's a huge number. Once you start, again, we know it's an even number, so divide by 2. That division by 2 goes pretty quickly. All right, so let's go ahead and do our upside down division. And let's figure out the cubed root. Remember, it has to be groups of 3 to count as a factor in my cubed root. Get going.
This is a lot of work.
Did you get 2048 on that first division? Okay.
Except 48.
Ooh, that's not good. You got to do that division right. All right, 2 goes into 512. Okay, 256, 2, and 28, 2. Is this all twos?
Yes.
64. Just 5 more. 32. 16. But it's not like it's hard. It's just long. All right, almost there. Okay, now how many do I need to have a group?
3.
I need 3. So I got 1, 2, 3, and 4. So what is 2 times 2 times 2 times 2? 16. All right, so my cubed root of 4,096 is 16. All right, so it's not that it's difficult, but sometimes it gets a little longer. That's about as big as you're going to see the numbers. So I kind of like looked ahead to try to put in some of those big numbers. Now, thankfully, in our examples, we're getting back down to some of our smaller numbers. So these are ones that I want you to have memorized. You don't want to have to be doing that upside down division for an 8. You can memorize the cubed root of 8 is 2. All right, there's only one number that can be multiplied by itself 3 times to be 8. It's 2. All right, so now the cubed root of negative 27. Anybody remember the cubed root of negative 27? Negative 3, because it's the negative cubed root. All right, and now I have a fraction, which means the cubed root of the numerator and also the cubed root of the denominator. That's important because on some problems, not today, but later in the chapter, you will be able to take the cube root maybe of the numerator, but not the denominator. So it's important you realize they can be split. The cubed root of 1 is 1. Anybody remember 64? What's the cube root? 4. So it's going to be 1/4. All right, you see these are going to be a lot easier if you have some of these basic ones memorized. Okay, memorize those basic perfect cubes. It'll save you a lot of work. So what if I had an expression now? So now I have actually some multiplication or addition that I have to do. I've got this 2 out in front, which means that I'm multiplying 2 times the cubed root of negative 216. All right, let's see, Kelsey, what's the cubed root of negative 216? Negative 6. So I'm going to take negative 6, and I'm going to say 2 times negative 6 is negative 12. Okay, you see how I did that? I evaluated my cubed root, and then I multiplied it by the number out front. Anybody notice anything about my second problem?
Which one?
Mason, you see anything? No? Nothing sticking out to you?
Yes. It got 2 3s.
It got
Not 2
It
3s.
cubes. Because it cubed. Or
Twice.
this one,
It cubes
yeah, cubed twice.
6
So it
times.
cancels out.
Okay, there we go. All right. The cubed root and cubing the same number cancel each other out. If you recognize that, you don't have to show any work. You won't have to show any work. Okay? So if you recognize those opposites, you won't have to show any work. All right. I want y'all to do the next 2. Raise your hand when you have the answers. I'm going to come check. All right. So what is the cubed root of 8? What is the cubed root of 8, guys? Guys, pay attention. It's 2. So 18 minus 4 times 2. So you see how I wrote that? It's all together. So 18 minus 8 is 10.
Yes, sir.
I did it.
Okay? All right, now, did anybody catch what was happening here on this first one?
Cancel.
It cancels out. So now you just have negative 64 plus 43, which is negative 21. Negative 21. All right, now in example 3, I'm solving an equation. All right, this is so similar to what we did with square roots. In order to undo a square, I took the square root. So in order to undo a cube, what do you think you're going to do? Take the cubed root. Take the cubed root. And whatever you do to one side, you have to do the same thing to the other side. Also, guys, make sure you have that 3 index. That's this number above the square root. That shows the cubed root. Otherwise, it looks like a square root. You say, well, Skinner, you know what I meant? Yeah, not really. Okay, you have to show it. So x equals 6. And it can't be negative 6, because if I multiply negative 6 3 times, that's negative 216, which is not true. So for a cubed root, my answer will either be positive or negative. Yes. To get rid of a fraction, you have to multiply by the reciprocal. Cancels out. But whatever you multiply by one side, what do you have to do? You got to do it to the other side. So 2 times negative 4 on the other side. N to the third equals negative 8. Then what?
You have to,
Cube root it.
I was about to say.
Cube root it. Don't forget your 3 index to show the cube root. N equals negative 2.
I get it.
N equals negative 2. All right, we're going to do one more. All right, so we're not going to do this very last problem because I want you to be able to get to your classwork. Okay, there's going to be 2 steps here to get to your answer. Raise your hand when you have the answer. So step 1, divide by 3 both sides. And b to the third equals 343. Say, well, I don't know what the cube root of 343 is.
I know
I
it.
got it.
Upside down division.
Can I say it?
If you have it memorized, Nick, what is it?
7.
7. If you have it memorized, you just answer it. B equals 7. Okay? So that's why memorizing your perfect squares and your perfect cubes are so important. So important. All right, so let's get started on our classwork assignment. It is going to be graded. It's like 7 questions, but it's not graded until Friday, okay? So between today and tomorrow, we're going to get a lot of classwork time in. We've got a solid 15 minutes right now to really get going on our classwork. All right, and that's it for 9.3.